Hello and welcome to this video that's going to demonstrate how to graph different sine and cosine functions using transformations. If you're here, we're assuming a couple of things. One is that you have done lots of transformations before on non-trig graphs, things like transformations of quadratics and the square root function and what have you. Okay, same for absolute value function, and you understand the nature of how we transform graphs. So the vocabularies of vertical shift, horizontal shift, and vertical stretch or compression, horizontal stretch or compression, these are not unfamiliar terms to you, okay? Now, the one thing I'll say is that when you get into trig graphs, because of their periodic nature, how we handle horizontal compression and stretch is a little bit different. You have some options there. You can do it the way you always did in other transformations, but you could use the nature of the period and cycle length of the graph to do it a much different way. Because of that, I'm going to dedicate a different video to dealing with how horizontal compression and stretch can be handled with sine and cosine functions, and we'll focus strictly on the nature of period when we do that. But in these examples, you might see that we'll have horizontal shift and vertical shift, okay, as well as vertical stretch or compression. All right, so another thing that you have to be really fluent by the time you're here is you can graph the basic functions of y equals sine theta and y equals cosine theta very quickly, okay? Be able to slap those up here decently quickly, and we'll say that we're going to start the sine graph with an output of 0, and 2 pi later it'll be 0 again. Right in the middle it'll be 0. Then between those two zeros it goes up the 1 and down the -1 between the second two zeros. Okay? Similarly, you have to know cosine like the back of your hand. First output for cosine using this input at 0 is 1. 2 pi later, the cycle ends, and you get the same output. Between those 2 points at pi, it goes down to the minimum of -1. So now you've sort of split the graph in half. In the left half, at pi halves, it's 0. And at the right half, at 3 pi halves, you also get a 0. Okay, so if you notice these are done on graph paper, the examples I will do in this video will be on graph paper. I'm planning on making some other videos that talk about not doing these transformations on graph paper where you would focus on data tables and then make sketches. But if you're looking for graph paper examples, you're in the right place. Okay, so let's take a look at what we have here. Please graph 2 cycles of the following function. Include 5 points of the parent function. Sorry for the blip there, I just wanted to change the problem. So what we have here, we'll be graphing y equals 3 sine of theta minus pi quarters plus 2. Not much different than other transformations. You'll see me do, I'll make an ABHK chart. These are the parameters that affect the parent function. A and B are the multiplicative values for affecting the output and input respectively, and then H and K are values where we will be adding or subtracting to the input or output values respectively. Okay, so you should have a sense of being able to identify those from having done transformations before. So what do we have here? We've got A is equal to 3, B is equal to 1. Now you might not be able to see that, but right here, that's what's going on, where on the inside of that set of parentheses is where I'm doing no multiplication, which means I'm multiplying by 1. Like I said, that's going to affect any horizontal compressions or stretches, which I won't do in this video, so it shouldn't be a shock. And then we see that H is pi quarters, and because it says minus when we look at it, we're going to shift to the right. Then it becomes important to realize that each grid is pi quarters in my graph paper here. So it really means, although you're going pi quarters right, it's 1 grid. And then it says that K is 2, which will give me a shift of 2 units up. So how do I do this? Not much different than I've done in transformations in the past. The first thing I'm going to do is start with the parent points for sine, which go from 0 to 2 pi. And pi in the middle, up at 1, down at -1, in the left and right portions of that, respectively. Okay, however you slice that up, it's fine. You got to get on your paper. You got to get those 5 points down very quickly. Okay, as always, the first thing I'm going to do is any multiplicative transformations. So I'm going to multiply all the output values here by 3. And I'll go in order here. 3 times 0 is 0. 3 times 1 is 3. 3 times 0 is 0. 3 times negative 1 is negative 3. And 3 times 0 is 0. Okay? So you'll realize when I did that, I said 3 times this, 3 times that, 3 times this. Okay? It was always that I was multiplying by 3, and I just looked at my red X points there, the red X marks, and I read the output value, because you're multiplying the outputs by 3. From there, it's decently simple, because I've got a battle plan here that says what we're going to do is move 1 grid to the right and 2 grids up. So I'll do that from each green box and go 1 grid over to the right and 2 grids up. I'll put a point because that's the final answer. Next green box, 1 over, 2 up, which is a little off the graph, but I can visualize it. Next green box is 1 over and 2 up. Next green box is 1 over and 2 up. And next green box is 1 over and 2 up. This gives me 1 cycle of the graph, and the directions ask for 2. So now the only thing I need to be able to do is create another cycle. And if you notice, going to my right, I would sort of run out of graph paper, so I'm going to need to put a cycle over here to the left. There's a couple ways to handle that. The one thing you could do is count the cycle length, and you can say that's 2 pi, so it's 1, 2, 3, 4, 5, 6, 7, 8 grids, okay? And then what you can do is take each grid and count 8 to your left and put another point, okay? That's the long way and the short way of doing it. You can do it a little more geometrically, okay? And do it a little bit more visualization, okay? And say, well, if a cycle length is 8 grids, I'll go 8 grids from the starting point to my left and go 1, 2, 3, 4, 5, 6, 7, 8. Now you couldn't see me counting on the smart board there because I didn't want to put marks on it. Okay? And then you realize that this would be the beginning of the cycle and that would be the end of the cycle. So to find the middle, I would go to 4, and I see that that point is in line with these. So I'm going to go 4 to my right from this far left point, 1, 2, 3, 4. Okay? Then if you notice here, you've got this left hump which goes up, and it goes up where? In the middle, which is 2 grids apiece. So here, then I'll go up, and then it puts me here. And similarly, if you look in the right part here, you realize it's 4 grids, so halfway to that is 2. And then I'm down 3 grids. So I'll go right 2 and down 3. And then that will be my second cycle. So we have 2 cycles, both of which are 2 pi wide. Again, because there was no horizontal stretch or compression, which I'll show in another video again, handling it via the period. Okay? So that is pretty much how you make a transformed sine wave that has a vertical stretch and a horizontal and vertical shift. So we'll take a look at the next example. And again, the directions say, please graph 2 cycles of the following trig functions. Include 5 points of the parent function. So here we're going to graph y equals -2 cosine theta plus 3 pi quarters minus 1. So again, I'm going to make an ABHK chart to see my parameters for that. If you've been in my classes, again, ABHK are not foreign ideas when you're dealing with transformation. So multiplicative parameter of the outputs is -2, for the inputs is 1. So that again is coming from here. So there's no horizontal compression or stretch. Then we're going to go 3 pi quarters to the left, right? Because it is -3 pi quarters. Again, the little thing I use, it's the opposite of what you see being added or subtracted to the input. Okay? And then I'll have to notice, again, on this scale, if pi quarters is one grid. 3 pi quarters is in fact going to be 3 grids to my left, and my k value is -1, which is a shift down of 1. All right, so how does this work? Same as it always does. Start with the parent function, but for cosine, we start at 1 and end at 1 on a 2 pi cycle. Between those, we're at -1. Between those 2 points on my left, we hit a 0. Between those 2 points to my right, we hit a 0. Okay? Now, I am going to multiply all the output values of those points by -2. So -2 times 1 is -2. -2 times 0 is 0. -2 times -1 is 2. -2 times 0 is 0. -2 times 1 is -2. Okay? So if I stopped there, you would get sort of a wave like that, which you can see has been flipped upside down from the original parent function. That makes sense because of the negative value of a. However, I am not done. I do need to do my shift and draw another cycle. So I'm going to go 3 grids to my left and 1 grid down. And I'll put final dots for that because that'll represent the final answer in terms of the first cycle. So we're going to start here. And for each of those points in green boxes, we'll go 3 grids left and 1 grid down. So we get 1, 2, 3, and then 1 down. 1, 2, 3, and 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 1 down. This represents 1 cycle of the final answer. Okay? Now, because I shifted left, there's some room to my right, so I'll wind up putting a graph in there, and we'll do that more formally by seeing that the period is, again, 2 pi, because there was no horizontal compression or stretch, which will give me 8 grids. So we'll go 1, 2, 3, 4, 5, 6, 7, 8. Okay? We had some room there to do that. And then in the middle of that will be 4 grids, right? So here, if I split that in half, it'll be 1, 2, 3, 4 grids. So that'll allow me to come up here and find this point. Okay? And then 2 grids to my left will be level here. 2 grids to my right will be level here. Okay? So that is going to give me my second cycle. And again, you could sort of do a check here by saying that each transform point in the second cycle is 8 grids to the right of this cycle. So let's take this point here, okay, and count 1, 2, 3, 4, 5, 6, 7, 8. I'm landing right where I want. Okay, here I'll go 1, 2, 3, 4, 5, 6, 7, 8. I'm landing right where I want. That part's not actually a transformation, although it feels like it. It's just the additional second cycle of the periodic graph. All right, so I hope that that gives you a sense of how to do a sine graph and cosine graph that has a transformation that, again, b equals 1, which means there was no horizontal stretch or compression. Make another video for that, and I'll try and make a couple other videos where you can actually do these without graph paper. Okay? If you're curious about that real quickly, that comes from doing data tables and then just making a sketch. Okay? So enjoy, practice, share. Thanks for your time.